All right, let's dive into this. You sent over some seriously interesting stuff for this deep dive.
Oh, yeah.
Yeah, we've got research frameworks, code, even a whole book. And it's all about intelligence, how it works.
Hmm.
So we're going to tackle a big question. How could a machine learn and use knowledge, like really use it the way we do?
It's a huge question. But, where do we even begin?
Well, maybe we start by thinking about memory, but not just storing data, right?
No, not at all. It's got to be more than that.
Right, like a system that can actually understand and build on what it learns.
Exactly. How do you even make connections, draw conclusions, maybe even predict what's going to happen next?
Yeah.
That's when things get really interesting.
I know, right? So to get a handle on how people are even tackling this, you sent over this AGI Research Framework.
Yeah, that's a good starting point.
And one thing that really stood out was just how organized it is. They have separate databases for tracking research and logging experiments.
And all that documentation, yeah.
Yeah. So is it kind of like a super detailed lab notebook, but for AGI research?
Yeah, you could think of it that way.
But why is that so important?
Well, think about it. Every little tweak, every observation, every time something unexpected happens, that's all valuable information, data, right?
Yeah.
And by keeping track of everything, researchers can, they can create a feedback loop, constantly refine their understanding and build on what they've already discovered.
It's not just about writing down what happened. It's about figuring out why it happened.
Exactly. And then how to use that to move forward.
I can see how that would be so important in, well, any field, really. Like learning a new skill, for example. You got to track your progress, figure out where you're messing up, and change how you're doing things.
It's the same idea.
But for AGI.
Right, precisely.
Yeah.
And they're using some pretty cutting-edge tools to manage all this information, too.
Oh, yeah.
Yeah, things like Notebook LM for working with research papers, and vector databases like FAIs and Pinecone to analyze how different bits of information are related. They even talk about integrating all this with Google Colab. Imagine that.
Wow. So researchers would have this incredible amount of computing power, right?
Right at their fingertips to test out their ideas.
Okay, so we've got this super organized framework and these crazy powerful tools. But what does an AGI memory system actually look like in practice?
Well, that's where that GitHub Cognitive Computations memory repository you sent comes in.
Oh, right. Yeah.
It's like a blueprint for actually designing an AGI memory system.
And what's it like?
Well, it's structured around different types of memory, kind of like how our own brains work, working memory, long-term memory, even things like semantic and episodic memory.
Oh, wow. So it's like they're trying to mirror the human brain.
In a way, yeah. But what I find really cool is how they're dealing with the actual challenges of building and maintaining this thing. Things like database management, API integration, how to make sure the system can actually handle all the information an AGI would need to process, which is a lot.
And they're upfront about the limitations too, right?
Well, yeah, for sure.
They specifically mention that it's designed for a single AGI.
Right.
Which kind of makes you wonder, what happens when we have a whole bunch of these things all learning and interacting?
That's the next big question, isn't it? How do you build a memory system that allows AGIs to work together, share what they've learned, maybe even have shared experiences?
I know, that's mind-blowing. But before we get too far ahead of ourselves, maybe we should switch gears a bit. You also sent over this book, On Intelligence by Jeff Hawkins.
Ah, yeah, that's a good one.
And it offers this whole other perspective on how intelligence might work. And you guessed it, it all comes back to memory.
Memory is key, absolutely.
But what's really interesting is that Hawkins starts by talking about how frustrated he was with traditional AI. He thought early neural networks were too focused on just copying behavior.
Oh, I see. Without really understanding what was going on underneath.
Exactly. He even uses that famous Chinese room thought experiment as an example.
Right. Just because a machine can translate Chinese perfectly, does that mean it actually understands the language?
Hawkins says, not necessarily.
It's the difference between, faking intelligence and actually having it.
Yeah. And this is where his main idea comes in. He says intelligence is all about prediction.
Interesting.
And prediction, he says, depends completely on memory. Our brains are constantly making predictions based on what's happened before, and that's how we make sense of the world.
So we're, running simulations in our heads all the time?
Basically, yeah. Using our memories to guess what's going to happen next.
Think about it. Something as simple as reaching for a glass of water.
Yeah.
Our brain's already predicting how heavy it'll be, how it'll feel, even how much effort it'll take to lift it.
Wow. Okay, now I'm going to be thinking about that all day.
Yeah.
So how does this constant prediction actually work in the brain?
That's where Hawkins gets into the neocortex, that part of the brain that does, the heavy lifting when it comes to thinking.
Mm-hmm.
And he describes it as this hierarchical memory system, like a pyramid of knowledge where information gets processed and refined at different levels.
So like each level builds on the one before it.
Exactly. And that's how the brain makes increasingly complex predictions based on, well, all the patterns it's learned over time.
So it's like our brains are always building this massive library of patterns.
That's the idea.
Yeah.
And Hawkins thinks that's what we should be trying to replicate in machines, this whole pattern-based model of intelligence.
Hold on, gotta ask, how does all this relate to me?
What do you mean?
Like me, sitting here listening to this, why should I care about how a machine might remember things?
Well, think about your own life for a minute. How much of what you do every day is about prediction?
No?
Like when you're driving, you're predicting what other cars are going to do, when the light might change. You're even subconsciously adjusting your steering based on how the road feels.
Oh, wow. Yeah, I guess you're right.
And even in a conversation, you're predicting what the other person might say, drawing on your memories of past talks.
Yeah, you're right. I never really thought about it that way. I mean, prediction is, like, everywhere.
It is. And that's what makes Hawkins' theory so interesting. He's saying that this whole prediction thing, which is rooted in memory, it's not just some neat trick our brains do. It's the very foundation of intelligence itself.
Okay, yeah, I'm starting to get it. But Hawkins doesn't stop there, does he? He says our brains don't just predict the future.
No, he goes further, doesn't he?
They shape our reality based on those predictions.
This is where it gets really mind-bending.
Wait, so you're saying our brains create, like, a custom version of the world based on what we expect to see?
In a way, yeah. Our brains fill in gaps, smooth over things that don't quite fit, even distort our perceptions to match our preconceived notions.
So two people could see the same thing but have totally different interpretations.
Absolutely, based on their memories and biases.
Whoa, that's both fascinating and kind of scary. But if our understanding of the world is so subjective, how do we even build a machine that can perceive reality accurately? Especially if it might have, like, blind spots like we do.
Well, that's a great question. And it leads us to how Hawkins thinks we should be building intelligent machines.
Oh, yeah.
He says we got to stop trying to perfectly copy human intelligence and instead focus on building machines that are inspired by how the neocortex works, but, adapted to their own senses and environments.
So we're not building artificial humans.
No.
We're building machines that can learn and understand in their own way.
Exactly.
Yeah.
He imagines machines that could excel in areas we can't even fathom. Like, imagine a machine that can actually understand higher dimensional spaces.
Or analyze huge amounts of data at speeds we can't even dream of.
Right. But to get there, we need to figure out how memory and prediction work together to create intelligence.
Okay, I see where you're going with this. We've got the research framework, the blueprint for an AGI memory system, and now this whole mind-blowing theory of intelligence as prediction. But how do we actually build these intelligent machines? Like, what are the steps?
Well, Hawkins lays out what he calls a recipe.
A recipe.
Yeah, and it has 3 main ingredients.
Okay, I'm intrigued. What are they?
Senses, hierarchical memory, and training through observation.
Okay, let's break that down. Senses. So that means giving these machines ways to perceive the world, right?
Exactly. But here's the thing. We don't have to stick with just human senses.
Wait, what do you mean?
We could equip machines with sensors that go way beyond what we can do.
So a machine could, like, see things that are invisible to us.
Exactly. Imagine a machine with sensors that can detect infrared light, magnetic fields, even subatomic particles. It would be experiencing a reality that's totally alien to us.
That's whoa. What could we even do with that?
Think about it. Scientific discoveries, solving problems we can't even comprehend right now, maybe even understanding the universe in ways we never thought possible.
My mind is officially blown. Okay, second ingredient. Hierarchical memory. I'm guessing this is the tricky part.
Well, it's where we get to how these machines might actually learn.
Okay.
Hawkins says we need to build memory systems that are organized in layers, just like the neocortex.
Like that pyramid of knowledge we talked about.
Precisely.
Huh.
And that kind of structure allows the brain, or a machine for that matter, to make connections between things that seem totally unrelated.
And to make predictions about the future based on what's happened before.
Right. But there's one more crucial piece to this recipe.
Training through observation, right? This is where it gets tough, I bet. How do you teach a machine to understand the world without just programming it with a bunch of rules?
That's the challenge and the opportunity.
Mm,
Hawkins thinks we need to move away from traditional programming and take a more organic approach.
what do you mean?
Like, imagine exposing a machine to a massive amount of sensory data and letting it build its own understanding of the world through observation.
Kind of like how kids learn.
Exactly.
Yeah.
And while that's going to be tough to pull off, it could lead to machines that can adapt to new situations, solve problems we haven't even thought of, maybe even be creative.
Okay, this is all incredibly fascinating, but I gotta admit, it's also a lot to process. Like, we've gone from the nitty-gritty of memory systems to these huge philosophical questions about intelligence and what's even real.
It is a lot to take in,
Yeah.
for sure.
Yeah.
But I think these are conversations we need to be having now. While the tech is still in its early stages, I mean, AGI could be one of the biggest things to ever happen to humanity.
I agree, no doubt about it.
And it's up to us to figure out how to make it work for us, for the better.
Okay, deep breaths. So we've got this incredible potential, but we've also talked about the importance of emotions, intuition, those things.
Right.
How do those fit into this whole picture of intelligence as prediction? I mean, are feelings even predictable?
That's a great question. And it leads us to an even deeper exploration of what it means to be human.
This deep dive just keeps getting deeper. But before we go there, maybe we should take a break and come back to that in part 2.
Sounds good.
I think our listeners could probably use a moment to process all of this. It's a lot to take in.
Agreed. It is a lot to take in. So we were talking about how emotions and intuition fit into this whole idea of intelligence as prediction.
Yeah, because we don't make decisions based on logic alone. Right.
Right. Our feelings, gut instincts, all that stuff plays a huge role.
And those don't always seem very predictable, even to ourselves.
You're right. Hawkins acknowledges that, even though his book focuses mainly on the neocortex.
The part of the brain that handles, reasoning and patterns.
Exactly. He doesn't say emotions aren't important, though.
It doesn't.
No. He points out other parts of the brain are involved, like the limbic system. That's where feelings, motivations, that gut feeling come from.
But he thinks even those could be a kind of prediction.
That's what he suggests, yeah.
So, even our emotions are a way of anticipating what might happen based on our past experiences?
Think of it this way. Say you had a bad experience with something before. Your brain might trigger fear or anxiety when you encounter it again.
Even if there's no logical reason to be afraid at that moment.
Right, exactly. It's like your emotional system is predicting a threat based on a pattern from the past.
Oh, I see. It's like a shortcut. A way of making quick decisions without overthinking everything.
Exactly. Helpful in some situations, but it can also lead us astray.
Yeah, if we're relying on old or inaccurate patterns, makes you wonder, if we want to build truly intelligent machines, do we need to give them emotions?
That's a big question, isn't it? Could a machine ever understand us, make art that moves us, make tough decisions without feeling something?
I don't know.
Some researchers think artificial emotions are key for AGI to reach its full potential.
But others think we should focus on machines that complement us, not copy us completely.
Right. There's a balance to be found. Leverage their strengths, logic, speed, memory.
But also acknowledge what makes us human.
Empathy, creativity, yeah. Even our tendency to be irrational sometimes.
Makes sense. But then how do we even test if a machine is truly intelligent? We can't just give it an IQ test, right?
Hawkins says the Turing test is too limited.
So one where a machine tries to fool a human into thinking it's another human.
Right. He thinks intelligence is about learning, understanding, predicting. Those can be measured objectively.
So design tests that assess a machine's ability to build a model of the world and make accurate predictions.
Exactly. Like a self-driving car. You wouldn't just judge it on avoiding accidents. You'd look at how well it anticipates other drivers, adapts to unexpected situations, learns from its mistakes.
Okay, that makes sense. But designing those tests, wouldn't that be incredibly difficult to make them truly objective?
It would be challenging, no doubt.
We have to make sure we're not just measuring how well a machine mimics us. What if its intelligence is totally different from ours?
That's a huge point. It highlights the challenge of defining and measuring something as complex as intelligence.
We need to be open to the possibility that machine intelligence might manifest in ways we don't understand.
Or even recognized as intelligent at first.
So testing is tricky. But let's say we have a machine that passes all the tests, shows signs of intelligence beyond anything we've seen. What then? How do we interact with it?
Is it a tool, a partner, a rival? A whole new species.
Exactly. Those are the questions.
And the answers probably depend on how we design and develop these machines.
If we go in with the mindset of replicating or surpassing human intelligence,
It's easy to see it as a competitor, a threat.
right, like the robots taking over, but there has to be a more nuanced way to think about this, right?
Absolutely. Hawkins argues we should focus on AGI that complements human intelligence, augments it, rather than replacing it. Collaboration, synergy.
Not us versus them, working together, using the strengths of both humans and machines.
Imagine AI scientists collaborating with human researchers, AI artists creating art that blows our minds, AI engineers designing cities that are sustainable and in harmony with nature.
Now that's a future I can get on board with. But how do we even get there? It seems so far from where we are now.
It's a long road. But Hawkins emphasizes transparency and collaboration.
So no more secret AI labs.
Ideally, no. This needs to be open, inclusive. Scientists, engineers, ethicists, the public, all involved.
Guided by ethical principles with safeguards.
Right, to prevent unintended consequences.
We need open dialogue, different perspectives shaping this powerful technology. Okay, that sounds like a more hopeful path. But I have to admit, I still have some worries. What if we create something we don't fully understand, something we can't control?
Those are valid concerns. We have to approach AGI with caution and humility. But the potential benefits are just too big to ignore.
I see both sides. High stakes, but also a chance to solve some of humanity's biggest problems.
Climate change, poverty, disease, all of it.
So proceed thoughtfully, collaboratively, understand the possibilities and the risks.
Exactly. This isn't just about the technology, it's about philosophy and ethics too.
Yeah.
We're going to have to re-examine our own ideas about intelligence, consciousness, what it means to be alive.
Wow, heavy stuff. But I also feel inspired, like we're on the edge of a whole new era of discovery.
I agree. It's exciting and a little scary, but that's what makes it so captivating, this pursuit of AGI.
It's not just a scientific endeavor, it's a human one.
It's about understanding ourselves better, pushing the boundaries of what's possible, creating a future that's both intelligent and compassionate.
Well said. We've covered so much ground, from the details of memory systems to the big questions about artificial emotions and the nature of intelligence.
And we barely scratched the surface.
But we have a good foundation for understanding the key concepts and the big questions.
Absolutely.
You know, speaking of questions,
Yeah.
there's one that keeps coming back to me.
What is it?
We keep talking about machines surpassing human intelligence, but how do we even measure that? What specific areas might they be better than us in?
That's a good question. Human intelligence is diverse.
We're good at creativity, emotional intelligence, social stuff.
Right.
But machines, they might be better at raw computing power, data crunching, and finding patterns in those high-dimensional spaces we talked about.
Exactly. It's not about who wins. It's about recognizing the strengths of both humans and machines.
Makes you think, huh?
It does. And this brings up another fascinating aspect of AGI. Machines might perceive and understand reality in ways that are totally alien to us.
Oh, you mean like those machines with sensors that can see beyond human vision?
Exactly. Hawkins suggests they could unlock incredible insights about the universe, patterns we're blind to.
Wow, I'm starting to see that AGI isn't just about building smarter machines, it's about expanding our understanding of intelligence itself.
That's a great point. And it highlights the importance of approaching AGI with a sense of wonder and humility.
We might learn as much from these machines as they learn from us.
I think that's very likely.
Okay, I'm definitely feeling that sense of wonder and a little bit of what if, too. But that's what makes this topic so captivating, right? The excitement and the unknown.
Absolutely. It's uncharted territory. We don't know where it leads. But the potential is huge. And with careful planning, collaboration, and a commitment to ethics, we can create a future where AGI benefits everyone.
All right, I think our listeners are ready for part 3 of this incredible deep dive. All right, we're back, ready to wrap up this deep dive on AGI and memory. It's been quite a journey.
It has, hasn't it? And, for all the complexities we've talked about, one simple thing keeps coming up.
What's
patterns?
Yeah, you're right. It's like this underlying theme connecting everything, the research, the memory systems. It's all about patterns, isn't it?
Exactly. And it goes right to the heart of Hawkins' theory of intelligence. He says the neocortex, the part of the brain that does all that higher level thinking, it's basically a pattern recognition machine, constantly making predictions based on the patterns it's learned.
So patterns are crucial for human intelligence and for AGI. But Are there any types of patterns that machines might be better at handling than us? I mean, our brains can only handle so much, right?
That's a great point. One area where machines could really shine is dealing with huge, high-dimensional data sets. Humans were good at recognizing patterns in 2 or 3 dimensions, like faces or spaces.
Yeah, I get that.
But when things get more complex, our brains kind of struggle.
I can barely imagine a 4-dimensional space, let alone 10 or 20. So a machine could actually see patterns in those higher dimensions, things we can't even grasp.
That's exactly what Hawkins suggests. He thinks with the right kind of memory systems and algorithms, machines could easily navigate and understand those high-dimensional spaces. Think about the possibilities. Physics, cosmology, financial modeling, fields where the systems have tons of variables, complex interactions.
That's mind-blowing. But if we can't even visualize those spaces, how would we understand what the machine is seeing? How would we know how it's reaching its conclusions?
It's a tough question. We might need to come up with new ways of thinking, new visualization tools, maybe even new math, just to interpret what those machines discover.
Okay, wow. Maybe let's take a step back for a second. What about something like language? We're surrounded by words, sentences, stories all the time. How do our brains even make sense of it all?
Language is a perfect example of how our brains use patterns to extract meaning from all that information. We learn the patterns of grammar, syntax, all that.
Yeah.
And we use those patterns to understand new sentences, follow a story, even get humor or sarcasm.
Right, and we do it so easily most of the time. But machines, even with all their processing power, they still have trouble with the nuances of human language.
Exactly. They can translate text, write grammatically correct sentences,
Yeah.
but they miss the subtleties, the emotion, the intent, the context.
Because they're still using pretty basic pattern matching techniques. Right.
They don't have that deep understanding that humans have.
Yeah.
We draw on cultural knowledge, experiences, even physical sensations to interpret language.
So it's not just about the words themselves, it's about the whole world those words represent, the human experience.
That's it, exactly. And that's where Hawkins' focus on hierarchical memory comes in again. For machines to truly understand language, they'll need memory systems that can represent not just words and sentences, but the emotions, the associations, the cultural nuances, even personal memories that shape how we use language.
Okay, I'm following you, but that sounds incredibly difficult, almost impossible. How do you even design a system that can capture all of that human experience?
It's a challenge, but not impossible. Look at how children learn language. They aren't taught grammar rules explicitly. They learn by listening, interacting, experimenting with language in a social setting.
So we need to create environments where machines can do the same, immerse themselves in language, learn through trial and error, just like kids.
Precisely. A kind of language playground for machines where they can explore and develop their own understanding organically.
AI children chattering away, making up words, telling stories. It's kind of a cool thought.
It is, isn't it? And it shows the potential of AGI, not to replace us, but to help us understand what intelligence really is.
This whole deep dive has been incredible. From memory systems to consciousness, the future of intelligence. It's a lot to take in.
It is. But I think the biggest takeaway is this. The pursuit of AGI isn't just about technology. It's a human endeavor.
It's about pushing the boundaries of our understanding, about what's possible. It's about shaping a future where technology serves us in a meaningful way.
Absolutely. And on that note, I think it's time to wrap up.
To our listeners, keep exploring, keep asking questions, and keep an open mind to the possibilities that lie ahead.
Thank you for joining us on this journey. Until next time.